So, the reason I'm streaming right now is twofold, really. One is a new audio setup, and I want to see how well it works, but also, quite unexpectedly today, this turned up. You remember my previous stream on the Wanhao i3? I wanted a metal replacement for the filament guide thing, which this is. And so this turned up, and I'd also discovered that I couldn't mount the one that I had, the plastic one, which I'll bring out in a minute. I couldn't mount it the way that I wanted. I wanted to flip. I wanted to flip the cold side around. Sorry, the hot side of the hot end around. And it wasn't going to work because of where this hole was. If I flipped that around, I'd have to flip the whole kind of lever assembly around. So this is a left-hand side lever assembly. It's designed to go with the motor on the left as opposed to on the right, how it is by default. So I've no idea if it'll work. It's not to exactly the same specifications as the one that came off, but we'll compare them and we'll see if we can make everything work. For reminder's sake, get up my drawings, and I might need measurements again as well. So I'll keep those here. Yeah, let me get the old stuff, and we'll see if it works. It's in here. This is quite a heavy box. I also got another extruder gear with it, which I don't need. It's nice that it came with. This is the extruder gear that I do need, and this is the old lever. Seems like it might fit. This is the new. That's the old motor. This is the new motor. And if you remember last time as well, we had some trouble getting this gear on. I was actually wrong. I said this gear was brass. It's actually steel. And it looks kind of brass coloured because is it just because it's been heat treated? So that straw colour is the kind of colour that you get when you harden steel and then temper it back. Almost kind of brass coloured. So we'll try and get that on as well. I have a way to get that on. Even if this doesn't work, we can get that done. What do I need? I need some Allen keys to do this. Got some new Allen keys as well. New set. There's fireworks going on outside, by the way. So if you hear them, that's what it is. Not gunfire or anything like that. Should probably get a magnetic tray for all these nuts and bolts and things. Go and grab one in a second. Need this as well, obviously, to see that everything lines up. Okay, so it's going to have the wires exiting out the top. This can only really go on one way. And then the plan was, so this hole here, just above my finger, there, should line up with this hole here, ideally. they seem to line up pretty well. There's a gap. It's a bit of a gap, but the gap's not... Okay, they line up, but they line up, but again, we have this issue of like offset. So if I put this, if I flip this on top of here, as it's supposed to go, you can see it's not going to be in line. If you take a line vertically down from here, it's no longer in line with that. Show that with a ruler. I'm sure it's fairly obvious, but just to make it even more obvious, that doesn't line up. So I need to flip this around, flip this cold side around, which I wanted to do anyway. That was kind of the point of what I was doing. So let's see if that's going to work. I don't think there's another way to do that. Is there? Yeah, there's no other way to achieve that than rotating this 180 degrees in that direction, right? If we do that, then it should fit, hopefully. So let's do that. I'm going to need some way to clean it as well, because it's going to make a mess. Because there's thermal compound in there. Before I do any of that, I'm just going to check the thickness of this, because the entire point of this is to get this thinner. And this was supposed to be 15 millimeters thick. I believe this one's 15 millimeters thick, but if it's any thicker, then we're obviously losing out on that advantage we had, which was kind of the point of doing this. So I think 15 or 15.5 is what I want. That's 15.5. And this is... Can't even be bothered really to check all the measurements and to make sure this is going to work out. I kind of trust my past self for having done it. This is 15.3. So we say 15.5. Okay, so just go over the plan again. If this goes this isn't exactly what I wanted to do. What I wanted to do was to rotate it in this direction, not this direction. But the net effect, I believe, should be the same. There's only one way to find out, really. And this is obviously going to put the motor on the other side, but I could then just flip it back and yeah, let's see. I can't quite remember. If I flip it back, then we're back to square one, right? We're going to have this further to this side, which is not what we want. We want to go away from that. We want to move that to that side, to the right hand side. I know I'm talking to myself here, but that's kind of the point of live streaming, isn't it? That's not the point of live streaming. That. Right, let's get this flipped around. There's a bolt here, which kind of, this is an upgraded version of this cooling block, and it has a, so the standard one just has a grub screw that basically pushes into the side of the heat break here. This one clamps around it instead, so it's got a small slot there and a screw here, which kind of brings it's kind of like a flexure, I guess. It kind of compresses the metal towards and around the cylinder there. Just to be super accurate as well, I'm just going to measure the depth, the amount just get a good draw. There we go. The amount that it sticks out where my finger is, where my index finger is here, the amount that that's protruding from the surface. So we can make sure we get that roughly the same as well. That is 0.5, almost exactly 0.5 millimeters. So let's leave this wrong size. Also wrong size. Okay. So I wonder if that's a Is that a 1 point? That's a 2. No. 2.5 maybe. No. It's got to be. It's a bit chewed up, but it's not a 2 and it's not a 2.5. Let's try a screwdriver. It did, like most of these things, come with its own Allen key, but I tend not to use the ones that come with things. Okay, not that. To this. Not that, it's too small. Don't really have anything bigger. It talks. Yeah, okay, that fits. Not ideal because it's a Torx and this is an Allen bolt, but there you go. You can see there's some thermal compound on there. Hopefully I don't need to reapply any and I'll just put it back and tighten it up again. Just kind of loosely tighten it for now, because things are going to change. Okay, so now these should line up when they... What's going on here? I've just confused myself a lot. What's going on here? That should line up with that, which it doesn't. It's a good start. Oh, it's upside down. This is why I shouldn't do these streams at night or do this kind of work at night. There we go. That lines up. But these holes are now further down than they were before. So I'm not sure that's going to work at all. That will go there. Yeah, that's not going to work at all. That's a shame. Okay, let's just try, let me get this out completely. Let's just try and get it in a position where it fits physically. And see what we need to do to make the rest of it line up. So that goes there like that. This goes on top. It's a bit of a gap, but that's fine. And yeah, that doesn't work at all. So the left-hand side version of this doesn't do what I want it to, really. I'm not sure if the right-hand version of this would have done what I want it to. Unless I'm missing something, I don't think this is going to work. Just going to screw it on actually, just to get the rest of the stuff lined up. So that means taking this out actually. spring's going to come flying out as soon as this is loose. Okay, there we go. What went there? Okay, nothing. Okay. So that fits on the motor quite well, which is expected. Cinch it down a little bit. Okay. And now, okay, that's loose. It'll be loose. This bolt might be too long for, yeah, okay. Bolt's too long for the motor, but we can fix that. So now, have a hole there for the filament to come through, and it needs to match up with this, which it does with that space actually. It looks like it's lined up like that, which is with the block kind of separated on this. I don't know if you can see it, there's a little lip there on the motor. So if I line it up how it was before, where it's flush with the body of the motor, those holes don't line up, but then they seem to line up if you let it sit on top of that gap. So maybe it needs a spacer, which adds some distance. Measure what that distance is, just roughly. Looks like about 1 millimeter. Yeah, it's over 1 millimeter. It does look like it lets everything line up. I'm going to need some spacers there to make that work. If I do that, okay, it still doesn't line up in that direction because I've got it the wrong way around. So if I do it that way up, then it no longer lines up at all. It doesn't line up. Ah, okay. Yeah, that's how it's meant to be. So there is a small gap there. It's flush against the motor, and the hole's in the wrong place. If I flip it over, what am I doing? Flip it over this way. The hole's no longer in the right place. Very confusing. I did say this wasn't the right, this didn't have the right dimensions, right? I'm wondering if there's anything I can do to modify it. I guess just re-drill this hole and re-drill. Yeah, okay, that's going to be a challenge, right? Re-drilling that hole because it's kind of tapped in the top. Bring it up. Focus. Bring it up to the camera. Yeah, so that's quite a complicated machined part there. Okay, in focus, there we go. So not very easily done, that one. Okay, let's get this back together. Wrong one. There's no one here for me to ask about the sound, but I guess I'll listen to a recording. One thing I have noticed is like tapping on the desk and things interferes with these microphones quite a lot because they are connected essentially to the desk via an arm. Okay, so let's put that back. Put this back. this was a fail. Maybe the mirrored version of it will work. My brain's a bit frazzled right now to try and figure out whether it will. Maybe I can retain the lever and reprint this part or something, because the hole is in the middle of the lever, so this should work in both orientations. Maybe a 3D printed replacement for this is what I need. Maybe even this lever with this. Ooh. That lever with that. Would that work? So it would need to be flipped. Can give that a go, because there's not much wear on this part. There's wear on the actual lever part that we took off last time. But maybe that'll work. For now, let's get the gear on to the motor, because that's fairly important. So last time we had some issues getting this on because the D-shaped shaft is just such a tight fit onto the new motor. But I was thinking, how am I going to press it on without kind of damaging the motor, right? Without damaging this back bearing. And I came up with a bit of a plan that should hopefully work. So I'm going to give that a go. The first thing I want to do is just to take a needle file to the inside of this and just make sure there's no sharp edges or anything snagging. I don't want to really use any abrasive on this shaft, but it's already been scratched up quite a bit by this. So just to make sure there's no kind of sharp edges that are causing it not to go on. So we needle files out, and half round or triangle or something that'll fit. Yeah, that fits. Just want to very lightly, so obviously I don't want to change the shape of the inside of this. Just want to very lightly just check that there's nothing protruding on the inside there, no kind of raised edges, and then just kind of, sorry, I'm not even showing you, just kind of deburr the edges as well. You might be wondering, if the gear is hardened, is this file actually going to do anything? And it is picking up some material. It is deburring the edge, so you can see your bevel there appearing. And I can feel the powder kind of coming off, which could be from the file itself, to be fair. Okay, let's see if it fits this time. It's going on a bit more easily, actually. Wrong way around, but going on a lot more easily. It doesn't even need to be pressed. Okay, that was a success. That's all I needed to do. I was actually going to use a drill vise and press it in, support the back of the shaft with something, and then press it on, but it seems to be okay. He says, yeah, it seems to be sliding on without issue this time. So that's a success. Let's just tighten it on in roughly the right place. So there's a little grub screw on the bottom here. I'll just line it up with the old motor. See the distance that it needs to go. It needs to sit. a lot more. That's actually the end of the D shaft, so it won't go any further than that. You can see there's a flat here, and here it's round. So hopefully that's enough. I'll just tighten it back up. So all that messing about with the heat gun last time was kind of pointless. I just needed to finesse the edges of this a little bit. Okay, that's on. Let's have a go at this. I wonder if this has a size on it actually. T10. That's not very helpful. Let's see if putting this lever on this base plate is going to do what I want. That's the wrong one. This is the wrong one. This is the right one. So this goes onto the motor here, like so, and then essentially this is flipped around, but okay, that's a weird way of adjusting it. It works, I guess. Is that looking like it might work? No, because the exit hole is here. You can barely see it, but there's a hole there. The entry hole is, actually no, they are kind of, yeah, they are lined up. I can see straight, you can see straight through as well. There, you can see light, my finger through there. So that might actually work, which is fortuitous. The one thing we're missing is the bearing surface here. So this is yeah. We need somewhere for that screw to go. So this side had a countersunk piece that went in there. You can kind of see it there. But we can maybe modify it. It's not going to allow me to get any narrower though. So the question is whether it's worth doing. Because the entire idea was that I wanted to flip this around. Just trying to remember now. Yeah, I wanted to do that. And that's something this isn't giving me the ability to do. That exit hole location seems really weird to me because the thickness of these is about the same, these two plates, and yet I can see the exit hole here, which means it's in line, yet the exit hole on this is in a completely different, it's offset by about 2 millimeters. I don't know if you can see that, but get this off. So if all of that's working out how it looks like it should, You can see there's a hole there, just in front of my index finger there, and this hole here, in front of my right index finger. They should line up, but they don't. I'm a bit confused as to why that is. Those two line up. You can see through here. There you go. See all the way through that hole. But this just doesn't line up at all. So I deliberately bought the left-hand side version of this because I thought it would allow me in some way to flip everything. I didn't really think about it in too much depth, but also it is designed for a slightly different extruder design. And thirdly, I guess, even if this were to go back together how it is, that's not what I want to happen. Even if this were to go back together, would this gear clear everything it's supposed to? It looks like it would. Looks like it fits through there fine, the heatsink, so that's not a big issue. But this is. So this is the standard layout. Get this into the way. This is the standard layout. And what I wanted to do was to rotate this. Rotate this so that if you look at the location of this hole, it moves from being to that side to being more towards this side. And that means that you would need to flip this entire assembly around. Which doesn't work just like that because of the lip in the motor. And there's a recess for it here. Probably more visible on this one. There's a recess here. So I thought if you get a left-hand side mount, then you can flip the entire motor, and most of these measurements still work out to have the effect that I want. But not all of them. And it's far enough out that that looks like it lines up, but it really doesn't. That really doesn't line up. And the complication is, like, I don't really like this layout. I don't like this big cold block. I don't like I don't like this hot end design, but I've already spent quite a lot of money on this heat break that is specifically designed for this. So anything I replace this with would have to be compatible with this hole size, essentially. This hole size here. Or I could modify something that I get, I guess. Maybe that's the way to go about it. Maybe I just reassemble it as is, get the machine working, because there's more modifications we want to do. Why don't I do that? let's get it all back together, and then we can do what we can in terms of modification, do the rest another time, do it in phases, because there's quite a bit more to do actually on that machine. So let's get it back together. Sounds like a plan. So we've got short countersunk screw here. Get the right size bit again. Not that one. Yeah. Spring. Using that. And then have the long bolt through here and through there. And we've got to compress this spring into place. There we go. Then just screw this in. I need to really, my brain, maybe it's just because my brain's a bit frazzled right now, or maybe it's because I really need to draw all of this up in CAD and see it in 3 dimensions in order to know what's going to work. I'm sure there are some off-the-shelf parts that I can modify to do what I need here. I'm just not seeing it right now. Just kind of, with this, I just kind of took a guess. I could have bought a left-hand side and a right-hand side one at the same time, but I didn't. I thought left-hand side would be sufficient, and it's not. Okay, there's that, and what else have we got? Okay, this, which goes that way up. With the heatsink on top, I'm not going to bother with thermal compound right now. There wasn't any in the first place anyway. And then 2 spacers, which are here. And then the fan, and then some long bolts. These countersunk bolts, I think I replaced. It had non-countersunk ones before, and countersunk ones just kind of keep everything in line a bit better. Fan's not there though. Should be in here, I'm guessing. I can't remember which fan I was using actually. Was it this? This is the original fan that came with the machine. I thought I replaced this. It seems I didn't. I thought I replaced it with a quieter one. But maybe not. Also mounted this the wrong way up. I wanted to have the wires coming out the top. Let's redo that. This is the way with things sometimes, unfortunately, or fortunately. Kind of encounter issues as you go, which means things don't work out how you had planned. Usually, some way along the way, you find it works out better in the end. wires coming out the top. Let's get this in. The nice thing about countersunk recesses is that you don't have to worry too much about alignment. The angle of the countersink keeps everything aligned as you assemble it. Kind of forces it into alignment. That countersunk screw there. So I'm just trying to line up this screw against the pressure of the spring down here. Go. So now take two. That goes there. This goes here. Two spacers and then a fan. I'm not sure which way up this fan goes, but actually I can look at the, because of the countersunk screws, I can see the marks of where it was before, so it was this way up. Strap these all the way through, like that. I don't know if it's even going to print with this on, which is why I'm not worrying about thermal paste right now. I just want to get everything back together and see how it kind of fits, and then yeah, maybe I'll use the other printer to print some replacement parts or something to make everything work the way that I wanted, or we find out that it works the way that I wanted without me having to do anything. So tighten this down. Like so, and then we'll get this back in, like that, and I'll just roughly tighten this up. That's not the right size, but still. This is where that weird torques. I wonder if that's like an imperial size or something. A really weird size. Okay. So I'm not tightening that up too much again because I'm not sure how long it's going to stay that way. Just kind of get everything together. So we do have our smaller motor on. Apart from the flipping thing I wanted to do, flipping this around, not like a substitute swear word. Apart from that, everything seems okay. So there was something else I wanted to do for this machine. Yeah, which was the base plate. Let's have a quick look at that. Where's my keyboard wobbly? Okay. Let's get our tools out of the way and let's reassemble this. Not really reassemble because nothing was actually screwed in, but that's a cross, not a hex in there. Is it going to come out? Yeah. Cool. So that sits in there. We had one small screw through here, one small screw through this hole here, and then this goes on top, and then another screw to essentially act as the bearing through here, like that. Okay, so let me find the baggie that this came in. With that as well. And with the gear. So the other thing that I wanted to do, that's kind of done, is look at this replacement base plate that I got. So I got this from China. Oh, was that legible? Okay. I guess this video is not going up because that had my address on it. But I got this plate from China, which is a replacement for. So it's like 3mm aluminium. It's a replacement for Wa alaikum assalam, Mushfiq. I'll speak a bit louder, see if that's better, because I do have new audio set up, but I don't know if it's any better. So this is, in fact, let me increase the gain on this mic. Filters. Is that better in terms of sound? Just let me know. Yeah, so you can see this is the steel plate that came with it. Quite thin. It's got some strengthening ribs in it, but it's already quite bent, as you can see. Hold it that way. Or that way. It's kind of bowed. You can't really see it that well. But I thought while I'm there, I may as well replace it with something a bit nicer. But when I do that, I also wanted to, my brain's really not working that well today. I wanted to replace the thermistor in the plate that goes on top of this as well, in the heating plate. That's the next thing I need to do. So that's this plate, and these two are kind of suspended with some springs in between them. So they're suspended like this. This moves back and forth as the y-axis, and this is a heated plate with some wires in it, and it has a thermistor that goes in the hole here, and usually that's just like a glass bead thermistor that then has some Kapton tape on top of it, and I wanted something a bit nicer than that as a solution. So what I did was I bought, find it. So this is the standard thermistor. This thing, just a glass bead. It's just kind of stuck in the hole, maybe with some thermal compound, and just kind of taped in place. And I wanted something a bit more permanent than that. So what I did was, if I can find it, there we go. I bought a thermistor that's, okay, that's a really short wire. Bought a thermistor that's on a threaded I don't know what you'd call this, threaded standoff, essentially. It's kind of potted into there. And I didn't realise it would be this crude, otherwise I would have just made one myself. But the idea is that I can tap a hole here and have this screw in. So that's the idea. So the main thing I was worried about was this spring here. So it's got this spring, and I didn't want it to protrude too far out the bottom, because obviously there's a gap that has to be there between the two plates. I think it's going to be okay. I think the only way to really know about this is to try it. So this is an M3 thread. I'll get an M3 tap, and we'll just tap this hole out. So got a couple of tap sets, just cheap ones, but they do the job. Okay, M3 tap. And could do with something to kind of put this on top of while I do it. We'll get to that when we come to it. Okay. This wrench is not a lot nicer than the taps that I'm using it with. I got the wrench on an Amazon deal thing. Stupidly expensive, but a really nice piece of kit. Okay, let's get, guess a box will do. Get it on top of here. Then I'm just going to lean down to desk level, make sure that I'm level as I'm going in. So there's a 3mm hole, I think, so it's just going to very lightly tap a thread in here. You can see the shavings kind of coming out, but I'm not going in super straight yet. Okay, that's a bit better. I think we're through. Yeah, we are through. So okay, we should have an M3 hole now that I can screw the thermistor straight into. It's a little bit rough on the top, so I'm just gonna countersink that somehow. Wondering the best way to do that is. Deburr it a bit with a drill. Make sure I'm lined up. Give you a better view of this as well. Not what I wanted to do. just going to do this off camera. Apologies. It's a bit easier to do it when you're not worried about letting people see. Still a bit of a blur there. Guess I could use some sandpaper or something like that to just flatten this off. There's a tiny bit of a blur despite the countersink. But for now, I'm just going to try and screw this in. No thermal compound again, because it should have quite a good thermal connection now actually. Yeah, that's going to work quite well I think. So you can see the little brass thermistor in there. It obviously does limit the distance that I can kind of squash this down on top of the other plate. I can just check that actually, because these are the springs I was using. So yeah, I can compress them all the way, I'm guessing, but it should be a better situation than I had before, and hopefully this connector on here as well will fit through some of the extra holes on here. Okay, so what I'm going to do, I'm going to add a copper washer here, and then I'm going to tighten it down, and then in fact I'm just going to deburr it first actually, because I'm going to put a glass plate or something on top of here, right? I'm going to have some kind of print surface on top, and I want it to be, see, I've already tried to flatten this out. I obviously want the print surface to be as level as possible. The question still remains of whether I want to re-level it for that reason. Let's just check. Is it flat or is it just... Yeah, there's definitely a bit of a burr there. I do have a deburring tool actually. Maybe that's the quickest way around this problem. I wonder if this will actually fit in the hole. And it won't. Is that going to work? Yeah, that does work. Okay. So the cutting edge just kind of skims the surface enough. I can keep it in. Let me know how the sound is, by the way, guys. I don't really want to break up the sandpaper right now, so this is my other option. It's not ideal. It seems to be working okay. Okay, we still have a bit of a burr happening there. The other thing I could try is a razor blade. This is just aluminium, so it should cut fairly easily with a razor, and I have some single-sided razor blades. If I can just remember where I put them. I think they're in the kitchen because they're for a glass scraper. Let me go and get them. I can't find the blades, but I can find the glass scraper itself. Actually, I'll show you. This is actually doing really good job actually. Leveling this out. I don't know why I can just get sandpaper. That's the right solution to this problem. So I'm making a bit of a mess of this. Okay. So if I show you close up, you can see, bring it a bit closer. Try and get it in focus. You can see the kind of ridge around the edge that the glass scraper has picked up and flattened out. It looks actually really flat now. Okay, so let me get a copper washer and let's install this thermistor. I wanted to see actually if this wire fits through any of the holes, and it doesn't really. It'll fit through here, which is the best we can hope for, I guess. And then there's obviously an extension cable which will take this all the way to the motherboard. So I need my box of M3 screws again. Should have in here. Washers. Got some copper washers down here. There is obviously an insulative layer on here, so hopefully there's no issues with shorting out, because that would be a fire risk if this copper shorted out, but it's in there. We just need to tighten it up. Don't need to tighten it now actually. What time is it? 9 o'clock. Okay, I was going to reassemble the base plate of the printer, but I think I need to decide actually whether I'm going to try and flatten this again. So I'm going to leave the stream here for now. And this one probably won't go up. It was quite boring. So yeah, I'll see you next time though. Maybe next time I'll just have a finished printer and I'll just show it working. But yeah, I'm very close to having 2 working 3D printers right now. One's completely working, which I showed on the last stream, and this one's very close. Not exactly how I wanted it. This didn't work out exactly how I wanted, but yeah, it's okay. It will work. It will all work. Just need to figure out what I'm doing with this and this plate here, and then I'll get it back together and show you what it looks like in action. Thanks for joining, guys. I'll see you next time.